Ba, ba, ba. So, welcome back. This is me doing my stream again for the second time ever. This evening, should be a pretty chill one. Got my peppermint tea. And if we look at the printer, same as last week, actually. Printing some components for a turboprop model. This particular piece is, if I quickly check, it's called the air intake cover and shaft spacer number 4. So there you go. Not particularly interesting, but that's what's printing in the background. But to the work in hand. For the sake of continuity, I'm going to pick up the model that I was looking at last week. I've made a little bit of progress since the last stream, so I've now modeled it out, and it's near enough there. I think where I'd like to get to by the end of this stream is to make this model 3D printable. So I've got a few little sort of modeling corrections to make, and then we're going to process this in such a way that it's going to be watertight and hopefully printable. Because a large box like this is actually quite a difficult thing to print. Let's see. So starting off, I've noticed already that these lugs are not actually joined with the main things. Let's just do Boolean union. Now, I wonder to myself whether this kind of way of working is really the most efficient, or whether doing Booleans is just a kind of made a mistake. Let's undo that and let's move those, mirror those two over to the side. Where's a good reference? There we go. Now, what I was saying is, I wonder whether Booleans are really the most effective way of modeling, or whether it's an inherited hangover from modeling with SolidWorks. But there you go. It's the way that I work. So we've got the inner cassette, we've got the outer case, we've got the Gridfinity feet. What I need to do is add the Gridfinity tray on top so that it's modular and stackable. Then we're laughing. Let's just Boolean all these on as well. And not that. I have got spare model over here. Which isn't radius. So I'm gonna copy that away. Just so I have a reference for later in case I mess this up. Because this is the annoying thing about Rhino. It doesn't have a feature tree. Again, if you're used to working with parametric workflows, SolidWorks, at work I use a Libre, FreeCAD, Fusion. There's a feature tree. Whereas this works a bit differently. If you make a mistake, you can't just roll it back. I find the workflow in Rhino is actually more similar to something like Illustrator than SolidWorks. Quick check up on the printer because it's the first couple of layers and I really want to make sure they're looking good. Yeah, that's looking fine, I think. Beautiful. So let's work on the base plate design. Sweet. Just thinking to myself what the best model this is going to be. No, I think I've already done this actually. Yeah. I've actually already modeled the baseline, the stacking base plate profile there. 42 mil square with an 8 mil radius. Let's see if we can it's as simple as possible. 42, 42. Fill it. Now it's actually an 8 mil. I don't know why that's cutting out. 8 mil diameter, which is radius of 4 mil. Move. Now, let's do a sweep. You're wondering why this surface is red and this is grey. In Rhino, surfaces have an inside and an outside. So for whatever reason, well, okay, I know the reason. It's because the curve has a particular direction as well. This has projected inside out, which is why it's red. In my settings, I've got it to show the inside face of the surface, which is really useful for me to immediately identify whether this is going to work. And right now it's not going to work. So I have to flip it. There we go. Now, because I'm doing lots of Boolean operation, is it Boolean? Boolean? Never know how to pronounce it. Operations. I need to cap this so that it's a solid. And we're going to copy that over. That top surface. This looks a bit up. I have that hard corner. Okay, let's go check out my reference. This is one that I downloaded from a generator. Round edges all the way along. Fine. Can I afford to do that on my model? There's space. Fillet edge. Next radius 4. Yeah, that's gonna really cause problems. Something I'm learning to deal with, and it's more difficult than it sounds, is accepting that done is better than perfect. Let's just try and get this model to a working state rather than absolutely perfect. What's going on here? Oh, that's the enlarged base plate dimension. $41.5. Too big. That's too big, and so is that. See, this is why the feature tree is a real value in parametric modeling. Not to worry though, doesn't take long. Lip. Cap. Cap just identifies if a poly surface has a hole in it, which is planar, meaning flat, and can be sealed off. If this bottom face wasn't flat, it wouldn't be able to cap it. But in this case it is, so I can just cap, really nice simple command, and it just seals off. Super simple. I'm going to reference that corner of the radius, and I'm going to stick this on. I don't want to. Let's take off orthogonal. Why are you like? There's a little gap. On our example, it's got a little rounded kind of platform. It's not absolutely sharp, which makes a good deal of sense. Then we can do this a bit differently. So, rectangle 41.5 by 41.5. Just double check what the distance is. Down here between these, I think it's 0.5 or 0.6 something. 0.5. Move that over. Move that over. I can imagine there's folks watching who are screaming at the workflow. And again, for me, I'm trying not to be perfectionist, trying to just progress, even if it's messy and incremental. I end up going back on myself sometimes. That's okay. Right, I don't know why I've been working mid-air. Did it. That corner. That corner. I don't even need to do that. I don't even need to do that. So. I sweep. I flip like that. But I explode and delete that surface. So explode is breaking up this poly surface into lots of individual surfaces. I'm going to delete the faces which will be facing other faces. And actually that goes for all the sides. I can do the outsides separate. Interesting. It's done these short sections on one side and long on the other, which is not the most consistent kind of modeling approach. Let's undo all that. Sweep that again. I wonder how well it's going to cope if I do it. Edge, it's not going to like it. I'm going to try and do this as a sort of mitre on the corner. I wonder how this will work. Might not. Flip. Explode. Alright, well that's sort of great. Worked better than I expected. Now delete these outside faces. And I can remodel the very outside. Move that away. Join those surfaces together. We're now back into a solid. Top view. Copy from. Make sure I'm selecting the corner of the curve and not the surface. Now I probably could do a linear array, but sometimes when you just start doing something, it's easier to finish than it is to pick up a different workflow, a different task. Okay. So now what I need to do is model in these little bridges, which should be simple enough. I just do a line across there and a line across there, and I say loft that line. Ooh. Okay, my zooming's a bit wild. To that line. Lovely. I can delete curves. Oh, why is that? Flip. What? What? Oh, it's twisted. I know what's happened. I know what's happened. Rhino gets really fussy. Not really fussy, because it needs to know this information. But it needs to know which side of the line I clicked to loft it correctly. So I'm going to click the right side of that curve. And the right side of that curve. Flip. Let's check the middle, see if it's twisted again. Not twisted this time. Lovely. I just thought of a way which would have been much quicker than the way that I'm doing it now. As you can imagine, the way that I'm planning on doing this is to do one more loft here, copy them all along, and then join them all together. But what I could have done, in fact, what I will do actually, because it probably will be quicker, even though I've just done this, is kind of cookie cutter approach. Planus. No, okay. Rectangle from that corner to that corner. Take that curve. Planar surface. Delete the curve. We've now got a cap on this whole thing. What I'm going to do is select all these poly surfaces. Let's finish that top surface, and I'm going to do trim. I'm going to cut out all the middle holes. Much quicker. Look at that. Now I should have surface which is joined and together that covers all the gaps. Brilliant. Save. Let's do ourselves a bit of a favor and join these before this gets out of hand. What I might do, draw that rectangle to delete it. Take that curve, extrude curve. I'm gonna do that again, but I'm gonna untoggle solid. So it's just 4 sides. Here we make sure I'm selecting it correctly. Right, join, cap, brilliant. Now, move the whole thing there. No, delete these. Move this, that corner. That corner. Brilliant. Boolean union. Now, modular. If I copy the whole thing, kind of up there. We can see how that plugs straight in on top. Very nice. Okay, delete that. Now, a lot of these curves are getting in the way. Let's move. Change layer. This lot really just a reference for sizing right. Okay, just tidy. So I've modeled these together because I needed to get all my dimensions and so on correct. But what I'm going to do now is separate them out. There's some more messy lines that will need to be hidden away. Let's give us more space. So these studs are going to flex with any luck on these tabs. That will allow this to slide into these holes, but it's not going to slide very easily unless there's a chamfer on that. Let's add a little bit more of the details that we need. Chamfer edge, next chamfer distance 1 mil. That's fine. That edge, side, that edge. Going to give us a little preview, and that's sleep. Done. Now, I've got to think about how this box would be printed. Am I going to print it on this face? On this face? I think without these little tabs, the obvious answer is on the base going up. And I think with tabs, I'm going to do it the same way. I'm going to print from the base going up. And here's why. The way this is going to print, if you are familiar with 3D printing, is in layers. We've got our first layer, and each layer, let's say each layer is 0.4. Read it. So 8, 6. So this is how it's going to print, layer by layer, working from the bottom going up. So the weak point is between the layers. These layers can easily sort of peel away. Not easily, but they do. That's where the weak point is. So if I'm flexing this button in and out this way, then I'm sure you can imagine if the layers were oriented the other way round, then it would break right at this bend almost immediately. Right? But if I'm orienting it this way, then that's going to be the strongest possible, most robust possible orientation for the layers for this particular feature. So that's what's driving that decision. Now, knowing that it's printing up this way, I can start to be a bit more resource efficient. I don't necessarily need these solid walls. I might want to keep them solid for kind of airtight reasons. I could put a lid on this. And you know, I might just do that. Is that flat? No, this one is. This is my reference model for the filament box, which is going to be in this little storage thing. Ah, yeah. Three. That corner. There we go. So the box fits within there quite nicely. Loads of room. So maybe later down the line, I'll design a lid to go on this, which is going to help make this box it's not going to be airtight. Okay. I'm making design decisions on the fly here. I'm not going to make this box airtight because the 3D printer filament can be stored in airtight bags. And I have those resealable bags. So I'm going to rely on that as being the airtight layer, and that this is purely for mechanical storage, which is excellent because now we can start to punch holes in this to make it a little bit more efficient. Hands up, those of you who know the most efficient shape for strength to volume ratio. You guessed it. It's the honeycomb. What side do I want? Midpoint of that. Okay, let's not do it. Okay, I'm now realizing how honeycomb work. Been a long day. Okay, that looks like it's Oh, that looks like it's on the wrong plane. Aha. That looks like it will fit. Nice. Don't know what that's. Just want the games. And I'm gonna offset by a distance of 2.5. So we have 5mm kind of struts. Now it's these ones that actually I want. And I'm gonna copy them over there. No, you know what I'm gonna do? I'm gonna bring that over there. I'm gonna do a bounding box around them. I'm gonna group all of that. Now I can move this, kind of center it in a way that makes a lot more sense. Center. Mid that way. Let's just see how it's did that right where I want it. Lovely. Ungroup that outer curve. Ah. Ah. Top fronts. This is a bit of a primitive way of doing things, but again, it works. Cap all those surfaces. They're all now solid blocks. And I can do a Boolean difference. Surfaces to subtract from, that surface to subtract with, all of these. Now I've punched some holes in it. Okay. We've been streaming for nearly an hour, and I can see that the print is getting pretty close, and I need to get ready for bed. So, although we didn't get quite as far as I would have hoped, we have made this model a little bit more optimized for printing, a little bit more lightweight, and started working on some features and details like the Gridfinity grid at the top and the buttons underneath in a somewhat inefficient way, but actually in an effective way, because what this is about is turning up, get some modeling work done on a regular basis. Great. Night night.